So in this video, I'm going to be talking to y'all about compound interest and the formulas used to represent this. And we're also going to go through a little bit of, word problems to make sure y'all understand the concept. And if y'all don't know what compound interest is, feel free to check out this video. Let's begin. This is a really important formula you got to know. It's A is equal to P times 1 plus R over N to the N times T power. P represents your principal. This basically, in the context of investing, this just represents kind of how much money did you invest. And R represents your annual interest rate. And in the word problem, this is usually represented by a percent. So let's say your annual interest rate is 4%. And most of the time or literally pretty much all the time, what you got to do is you have to convert like the percent into the decimal. So if my annual interest rate is 4%, I would just write 0.04 for R. Okay, just convert into decimal. Your N represents the amount of time that this value is compounded per year. So if I said, let's say my principal was compounded 3 times per year, well, my N value would be 3. If I say, let's say my principal was compounded annually, you can think about it as just yearly. So the amount of times that you compound this principal would just be 1 time per year because it's yearly. Semi-annually, this just represents you compounding this 2 times per year. So your N would be equal to 2. Quarterly. This represents, you're compounding this 4 times per year. So these are just some common vocabulary words that are kind of going to come up in the word problems. And it's important to know what they mean. And we have another N up here. We already know what that is. And time, your time value is going to be in years. A just represents the money that you get out from investing this money, your principal value. So let's say that Sarah invests $1,500 in a savings account that compounds interest quarterly at an interest rate of 4%. How much money will Sarah have in the account after 3 years? Now, the way that you know you're dealing with a problem that involves this formula right over here is if you're compounding your principal value a set amount of times per year. In this case, we are compounding our value quarterly, which is 4 times per year. If we compounded this value 3 times, 2 times, 50 times, we have a set value of times that we compound this per year. That's how we know we're dealing with a problem that involves this formula. So we're trying to find out how much money will Sarah have in the account after 3 years. So all we're trying to do is we're trying to find out the amount of money that Sarah gets out of this investment, right? So we don't know how much money Sarah gets out, but we do know that the initial amount of money that she invests, or the principal value, we know she initially invests $1,500. This is going to be multiplied by 1 plus, so this is 1 plus R, which represents our annual interest rate. In this case, our annual interest rate is going to be 4%, but make sure to write that as a decimal. So 4% is just 0.04 divided by the amount of times this is compounded per year. In this case, our problem says this is quarterly, so it's 4 times per year. And this is going to be raised to the NT power. So N, we know that's still 4, and the amount of time in years is going to be 3, right? Now, all we have to do is just plug this into $4. And that is how much money she gets out. Now, this formula is another formula for compound interest. Your value that you get after some amount of time is equal to the amount you invest, which is equal to P, right? This is still our principal value, times E. E is just a number. You can see it on your TI-84. I forgot where it was, but E is constant. It's 2.71. It's around 2.71, but it's like pi. It goes on forever, so it's irrational. R, once again, this is just your annual interest rate. And T is going to be your time in years. Now, what's the difference between this formula and the formula that we just saw? Well, the key word to know that you're dealing with a problem that involves this formula is, well, let's take a look at an example. Maria deposits $5,000 into an account that earns 5% annual interest, compounded continuously. That is the key word that you know that kind of you're dealing with this formula. Compounded continuously. This is like a really weird idea. But imagine if you invest money. All right, let's say you invest money, and literally every infinitely small amount of seconds, it's getting compounded. So this is basically you're compounding continuously, just means that your interest is added to the principal an infinite number of times. This is like a really weird idea, but kind of your first formula, your kind of principal is getting compounded over a fixed value, right? The fixed amount of time. For this formula, instead of kind of the interest being calculated at fixed intervals, like yearly, monthly, it happens every infinitely small kind of amount. So every infinitely small seconds. All right, so this right over here represents a very, very small value. Infinitely small value, as you can imagine. So every infinitely small amount of seconds there are, well, your principal is going to be kind of, your interest is going to add on to, your principal. Well, your initial principal is P, $5,000. An account that earns 5% annual interest. So this is going to be times E, right? So P times E to the RT. So R is 5%, right? Which is just 0.05. And your time is 6 years. So you just put that into your calculator to get kind of what she gets finally after 6 years. So the amount of money she kind of gets out. It's around this number, 0.29. And that is our answer. So kind of the key thing to get from these problems is that it's good to invest early, because money's going to build up. Emma invests $3,000 into a retirement fund, earns 3.5% annual interest, compounded continuously. How much money will she have in the account after 10 years? Well, we hear compounded continuously, so we're going to use this formula. So initial amount is 3,000 times E to the, this right over here is our annual interest, so it's 0.035 times the amount of time, which is 10 years. I just kind of plug this into the calculator. And you get $4,257.20. Now, the good thing about these two formulas is that they can also be used to represent population growth, but we're going to focus on investment for this video. That's going to be it for another video. Investor deposits 6% annual interest, compounded continuously. How long would it take for the investment to grow to $5,000? Now, when you hear this key phrase, how long, this represents that you're solving for time. We're trying to find out how much time has to pass for the investment to grow to $5,000. And because this is compounded continuously, we're going to use this top formula. So this is going to be, well, in this case, we know how much money we have in the end, right? We know that our final amount of money we get after the investment is $5,000, right? That's our kind of final amount. Initial amount is 2,500 times E to the percent, which is 0.06 times T. We don't know what the time period is, right? But we do know what our final amount is. We do know our principal amount, and we do know our annual interest. So how do we solve for T? I'm first going to start off by dividing both sides by 2,500. So this 2,500 and this 2,500 cancel out. So I'm going to get 2 is equal to, because 5,000 divided by 2,500 is 2, so it's going to be equal to 2 is equal to E to the 0.06t. Now what I'm going to do is I'm going to take ln of both sides. Ln is the natural log, and this is representing log base E. Now, one logarithm property that you're going to need to know is that log base x of x is just going to be equal to 1. So in this case, if ln represents log base e, right over here, ln of e is going to be equal to, well, we know ln is log base e, and this is log base e of e. So this means that, well, because this is in this format right over here, well, log base e of e has to be equal to 1. And that makes sense because e to the first power gives us e. So ln of e is equal to 1. And 1 times 0.06t is just going to be equal to 0.06t, right? 1 times whatever this is just going to be this thing itself. So I have ln of 2 is equal to 0.06t. And to solve for t, I just have to divide by 0.06. And I get that t is equal to ln of 2 divided by 0.06. Plugging that value into the calculator, I get 11.55, around 11.55 years. 11.55 years. And you can actually check this. So when you're doing these types of problems, I probably should have mentioned this earlier, but don't forget to check your work. So in this case, right, if we plug in 11.55 for our time, we're going to get 2500 times e to the 0.06 times 11.55. Let's see what this is equal to. And when you plug this into your calculator, you get 4,999.26. And that looks like this is the correct answer. The only reason why this value right over here isn't 5,000 is because I rounded to the nearest hundredth for years. But if you were to put like the whole answer into our equation, we would get 5,000. I just rounded it, so I just got a value that's close to 5,000. An investor deposits $3,000 in an account that earns 4% annual interest, compounded monthly. How long will it take for the investment to grow to $6,000? Annual interest compounded monthly. Okay, so because this right over here says it's compounded monthly, we know that this right over here, our principal, is compounded at a fixed amount. In this case, we're compounding this monthly. So that means that we're compounding this 12 times per year, right? Because there's 12 months in a year. Which means that we are going to be using this formula because it's compounded at a fixed interval. Now, we're trying to find out how long, once again, this how long represents that we're solving for time. So how long will it take for the investment to grow to $6,000? So in this case, we're going to be like, okay, $6,000, that is our goal. That is what we want for our final amount. $6,000 is equal to our initial amount, our principal, the amount we invested, times 1 plus r, which is our annual interest, that's 0.04, divided by the amount of times we compound this per year. Well, it's monthly, so there's 12 months in a year, to the 12, that's n, sorry, not bad, to the 12 times, and then we're solving for time, right? We want to find out how long it takes for it to grow to $6,000. So our t up top is unknown. Simplify this. We're, once again, same step. We're first going to divide by kind of this term in the front. So we're going to get 2 is equal to 1 plus 0.04 divided by 12 to the 12t power, or the 12 times t power. Next, what we're going to do is we're going to simplify the inside. So 1 plus 0.04 divided by 12, that's going to be equal to 1.003, and it just repeats on forever. So it's 1.003 repeating to the 12t power. Next, what we're going to do is we're going to take ln of both sides. If you have a fancy TI-84 calculator, I can show you kind of, you can just take log base 1.003 on both sides and get the answer quickly. But let's just say we're taking ln of both sides. Now, another property of logarithms is that if you have, let's say, log base a of b to the c power, so we have kind of the exponent, well, what you're able to do is you're able to drop the exponent down. This is equal to c times log base a of b. Just drop the exponent down. So in this case, if we take ln of both sides, right? ln of this side, ln of this side, we get ln of 2 is equal to 12t, right? We just bring our exponent down, times multiplied by ln of 1.03. Repeating. Now, how do we isolate t? Well, we can just divide both sides by 12 ln of 1.003, right? We divide both sides by 12 ln 1.003. So now this 12 cancels out, and this ln of whatever that is cancels out, so we're just left with t. So t is equal to ln of 2 divided by 12 ln of 1.003, repeating. So let's see. So good, I get that. This takes about 17.36 years. And that is our answer.